All right, today we're going to talk about perimeter and area in the coordinate plane, section 9.4. So continuing talking about perimeter and area, now today we're just going to talk about what happens when they are in the coordinate plane. So perimeter and perimeter in the coordinate plane. One way to estimate the area of irregular shapes in the coordinate plane is to count the squares on the grid. You can estimate the number of whole squares and the number of half squares and then add. The polygon with vertices A is -3, -1, B -3, 3, C 2, 3, and D 4, -1 is drawn in the coordinate plane. The figure is a trapezoid. Use the distance formula to find CD. So notice when I have diagonals in the coordinate plane, I have to use distance formula, or what else can I use? Pythagorean theorem. Either one of those, I can use Pythagorean theorem or distance formula to approximate or find what that distance is. Notice when I have vertical lines or horizontal lines, what can I do to find the distance? I can just count. Very good. So I get distances that are 4, 5, 7, and then CD comes out to be about, I think it's like 4.5 as a decimal. And then you can add them up to find the perimeter, which is approximately 20.5 units. And then to find the area, we'll use your area formulas. The average of the bases times the height. So 5 plus 7 is 12. Half of 12 is 6. 6 times 4 gets me 24 units squared. So we're looking at perimeter and area in the coordinate plane today. First thing though, number one, estimate the area of each irregular shape. Okay, I can estimate this area. Well, part of the ways I can estimate the area is I can kind of draw a composite figure around it. So I can kind of draw here a figure. And I have something that looks like that maybe. And then once I have that, well, I can cut it up into even smaller segments. Just like that. And now I have 4 small segments that I can find the area of. Okay, and again, I'm just estimating. Well, what's the area of the very, very top rectangle? Right here. What's the area of that top rectangle, Troy? 4. Well, what's the area of the next rectangle? Let's look at the next one, the long, skinny one there. What's the area of that rectangle? Anybody? 14. And then I do the next rectangle down. What's the area of that next rectangle? Anybody? 12. And then very last, I can find the area of that small triangle section there. What's the area of that small triangle section? Anybody? 2. And then to find the area of all of it, what would I do with those 4 areas? I would just add them up. 4 plus 14 is 18, plus 12 is 30, plus 2, I get approximately 32 units squared. Now, why am I going with units? Because it's on the coordinate plane. Yes, sir. I like 32. 32 is a pretty good answer.
Oh, well, they had a square.
31's pretty close.
Wait, if it's a half, round it up to 1.
I'd keep it as a half.
Okay, so like, you know how you counted on the top one 4?
Yeah.
You know how that last one really kind of like a half? So how'd you...
All right, using that same information, try number 2. Again, number 2, again, you can cut it down into a similar segment here. Something like that. No, I'd treat it as rectangles there. And again, you can cut down something similar like that. All right, number 2 here. What's a good approximate area? Ryan, what'd you say? About 39. Somebody had about 40. What'd somebody else have? Ooh. Did you say 45? Oh, 35? I think earlier today we had about 37. So anything around those areas are, again, good approximations. And we would always say units squared. Nice job. All right, next thing we're going to do. Well, what happens if we have exact figures? So it says, draw and classify each polygon with the given vertices. Find the perimeter and area of each polygon. So the first one is F is at -2, -3. So I'd plot -2, -3. G is at -2, 3. So -2, 3. H is at 2, 0. And I would connect the dots to draw in my figure. And what shape do I have here? I have a triangle. Awesome. Now, first thing I want to do is I want to find the perimeter of this triangle. Well, to find the perimeter, I need to find all the lengths. What can I do to find the lengths? I can count for one of them. Which one can I count, Martina? The vertical line. What's the distance of the vertical line? 6. Nice job. Next thing now I want to do is I want to find the other diagonal lines. What can I do to find the distances there? I can use what? Distance formula, or I could use Pythagorean theorem. So Pythagorean theorem, you can make a right triangle here, use Pythagorean theorem, or distance formula. Either way, work it out and find the other two distances. Take a couple seconds to try those. All right, so let's look at number 3 here. What are the lengths of the other two sides? What are the lengths of the other two sides come out to be, Max?
5 is 5.
5 and 5. So that makes my perimeter what then, Max?
16 units.
My perimeter is 16 units. Now, next thing I want to do is I want to find the area. Well, to find the area, I need the base times the height. If you think of rotating the triangle to your left or counterclockwise, you can get a base and a height right down the middle there. Okay, what would the height be there then? 4. The height would be 4. So I have a base of 6, a height of 4. My area comes out to be approximately what then, Jack? 12 units squared. Nice job. Again, think of kind of rotating that triangle on its side counterclockwise, and then you get a up and down triangle. Yes, sir.
Instead of having to rotate it that way, can we rotate it so like the 5s are on these lines? That'd be,
No, because you don't know those are perpendicular. Does that make sense? Heights measure perpendicular. All right, number 4. So let's plot the coordinates here. -4, 0. -2, 4. 2, 2. And 0, -2. I plot the coordinates. Quiet down. Plot the coordinates. Then I connect the dots. Now the dots are connected here. Next thing I want to do is I want to find all of the what? All of these side lengths. So using the distance formula or Pythagorean theorem, find all of these side lengths for me. Take a couple seconds and try these. Awesome. This is a square. What are the side lengths of the square? It's about what?
4, 6.
It's about 4.5 is each side length. So approximately then, what is my perimeter? My perimeter comes out to be approximately 18 units. Which then means my area comes out to be approximately... What's my area come out to be approximately? How do you find the area of a square?
18
Multiply them. 4.5 squared. So what do you get? 20.25 units squared. Nice job. That is correct. Alright, next thing we can do. Quiet. Next thing we can do. When a figure in the coordinate plane does not have an area formula, another method can be used to find its area. For example, find the area of the polygon with vertices -4, -1, -1, 3, 4, 3, and 2, -2. So if you look here, I have this irregular polygon in red. I'm kind of outlining it. Well, how can you find the area of the irregular polygon? Well, you can draw it in with a rectangle. So notice they drew over it with a rectangle. Then they found the area of the rectangle and then subtracted all of the different triangular areas. And doing all those triangle areas, subtracting all those triangles, then gets you the area of the irregular polygon. Okay, so again, it's just rectangles and triangles. So let's try number 5 here. I want to find the area of each polygon with the given vertices. Okay, so the first thing I want to do is I want to draw over this with a rectangle. So I cover everything up, and I make a rectangle. Now I want to find the area of that rectangle. Well, the area of a rectangle is pretty easy. Just length times width, or base times height. What is the area of the rectangle, Tom? Correct. So that'd be 48 units squared. Awesome. After I find that, then I want to find all of the areas of the different triangles in there. So let's start with the top triangle right here. What is the area of that top triangle? Well, all of these are nice because they're right triangles. So the base is 3, the height is 6. That area has, the triangle area is 9. And then we're going to do the bottom right triangle there. What's the area of the bottom right triangle? It has a base of 1, a height of 4. The area is, what'd you say? 2. And then I do the area of the bottom left triangle. The height is 3. The base is 5. Oh, wait. The bottom right one's not 2, isn't it? Isn't it 2.5?
Yeah.
I was going to say, that's not 2. It's 2.5. What's the bottom left triangle then? The height is 3. The base is 5. 7.5. And then what do I need to do to find the area of the quadrilateral on the inside? I need to subtract all those. So 48 minus 9 minus 7.5 minus 2 minus 2.5. When I subtract all those, I get my area to come out and be approximately, what's the area of the interior quadrilateral there, Troy? What'd you say? Isn't it just 29?
I thought it was 30.
It should be 29 units squared. Nice work. Okay, let's look at number 6 here. Same idea. I want to enclose it all with a rectangle. So I enclose it all with a rectangle. I want to find the area of the rectangle first. What's the area of my rectangle, Caprio? It is 42. Nice job. Now that I have the area of the rectangle, take a couple seconds and try and find all 4 of the triangle areas. Take a couple seconds to try those. All right, let's go through these. Number 6, what's the area of the top right triangle? So this area right here. What's the area of that top right triangle, Caitlin? Isn't it 3? 3? What's the area of the top left triangle? Camden? 5. What about the bottom left triangle? What's the area of the bottom left triangle, Ryan? 12. And the area of the bottom right triangle then is? Anybody? Because the base is 4, the height is 6. Should be 12. Half of it? Oh, you get 24, sorry. Base is 4, height is 6, 24, and you get half of that's 12. And then what about the area of the bottom right triangle? That's about to be about what, Ryan? 1.5. And then I subtract all those. So 42 minus 12 minus 5 minus 3 minus 1.5 gives me what, sir? 20.5 units squared. Nice job. And again, we can do all that by subtracting and using those composite figures. Last thing we're going to do is we're going to work on this here. We're going to do the same thing here. We're going to draw and classify each polygon with the given vertices, find the perimeter and area of the polygon, round to the nearest tenth if necessary. So let's plot the coordinates here. A is at negative 2, 3. B is at 3, 1. C is at negative 2, negative 1. And D is at negative 3, 1. And then I've drawn my coordinates. And who can recognize what shape I have here? I have a what? I have a kite. Nice job. On this kite, who remembers the formula for the area of a kite? What is it?
Wasn't it like half of D1 minus D2?
Yep. It's half of the diagonals multiplied together. So half of D1 times D2. Using that information, find the perimeter and the area of this kite. Take a couple seconds, try these on your own. So number 7, I think all of us found the area. You could do the diagonals times each other and then take the half. So the diagonal there is 4. The diagonal there is 6. 6 times 4 is 24. Half of 24 is. So my area is 12 units squared. Then I would have to find the perimeter. Well, what's the distance of the longest side to the nearest tenth? The longest side comes out to be about what? It's about 5.4. So that's 5.4 and this is 5.4. Well, what's the distance of the small side then? Distance of the small side is approximately what? It's about 2.2. Which means my perimeter comes out to be approximately what? What's my perimeter about? And you add up all 4 sides, anybody?
11.2.
No. It's about 15.2. Nice job. And number 8. If you're to plot the coordinates of number 8, you get negative 3, negative 4. And then you get 3, negative 3. And then you get 3, negative 2. And then you get negative 3, 2. And I connect all my dots here. What type of shape do I get? You get a what here? You get a trapezoid. Nice job. So take a couple seconds and finish up number 8. Find the perimeter and area of that trapezoid. So let's look at number 8 here. What does the area come out to be?
I got 21.
The area comes out to be 21 units squared. Nice job.
What's 9 plus 10?
Okay. And then you have to find the perimeter. Well, the perimeter of the left vertical line is 6, or the distance. Vertical of the right one is 1. What's the distance of the bottom line? Should be the square root of 37. Square root of 37 comes out to be approximately what? 6.1? And then you have the top line. Top line, you get 4 and 6. So you end up getting the square root of 52. Square root of 52 is about 7 point what? What's square root of 52? Is it 7.2?
7.2.
And now I add up all 4 of those. And you end up getting the perimeter is approximately 20.3 units. Okay, and again, using Pythagorean theorem or distance gets us those lengths on the outside. All right? Good work. Here's your assignment.